Welcome back to the Linux Academy Nginx Deep Dive. We've talked about setting up proxy servers, or reverse proxy servers rather, with Nginx, and now we're going to look at how we can utilize our reverse proxy to also do some caching so that if we know what the response is going to be from a server, we can serve up that content without ever needing to bother our application server with yet another request. So this allows us to once again exercise something that Nginx is very good at, and also eke out some more performance from the application servers that we have, because they're not going to be answering the same requests over and over again. And this can be really good, obviously, if you are experiencing a lot of load. Like Nginx can handle a lot of requests simultaneously versus something like a application server that's using Ruby on Rails or Django maybe. They can handle less, right? Nginx is written in C, it's highly performant, and it's optimized to handle a lot of requests versus something that's running Python, PHP, or Ruby is going to be, there so that the programmer can write something to handle some sort of situation, but inevitably those are less performant than what Nginx is going to be at just serving some bit of content. So once Nginx knows what to serve for a specific URL or a cache key, as we're going to find out here in a second, then it can serve that up rather quickly and prevent you from needing to go and scale out your servers and have a ton of application servers in order to withstand the load that you're going to get. We've talked about it numerous times up to this point, but the proxy module and the fastCGI module and the uWSGI module, they all pretty much work the same way, and they have a lot of the same cache attributes here. So we're going to be working with this cache, and for the caching segment we're going to do right now, we're actually going to use the fastCGI cache and work with our blog that we already have, because WordPress does some things that makes it easy for us to see different interactions with content. But you could do all of these same things using a proxy pass setup that you could do with fastCGI. So everything we're doing here, for the most part, you can just substitute fastCGI for proxy and it will work the same way, or uWSGI. But WordPress just happens to be a good example for us to kind of look at the benefits we can get out of caching. So let's go ahead and get started now. There are a few things we need at first. So proxy cache is going to be the kind of the main one. And if we look at this, it's going to request a zone. And a zone is a shared memory used for caching, which what this really means is it wants you to have a named cache on disk. And this is where we're going to run into the cache path. So if we look at fastCGI _cache_path, this will be actually how we define what our cache is going to be. And there are a lot of options that we can get through here. So we're going to create one that's going to be for our blog, and it's going to go into the var cache directory. And we'll go through not using all of these because unfortunately, some of these things like the purger, these are parts of Nginx Plus that we don't actually have access to, even though they're here. But for the keys that we're actually going to be using, we'll talk about them as we write it out. Let's go ahead and modify our confd blog.example.conf. And one thing to note is if we go back and take a look at the cache path, you'll see that it needs to be in the HTTP context, which means it's not going to be inside of our server block. So for that, we're going to go to the top of the file, and we're going to do fastCGI cache path. And then I'm going to go ahead and put a new line there and kind of break this out a little bit. But if we look at this, the first thing we need is a path, and then there are going to be a bunch of different options. But you'll notice that these with the square brackets are going to be optional, but then there are some still that are required. So key, zone, and name is going to be the one that's required, and everything else is optional. We're going to put them in this sort of same order, though. So we're going to do a levels after our path, and then we're going to put a key zone in here. So ours is going to go to var cache nginx blog, and then the levels. This one is a little weird, and you're always going to see the same configuration for this. In all of my searching and looking into the research that I did for, really understanding Nginx myself, this is what I found every single time. And what this levels key does is it sets how many subdirectories should be used in order to store things. So the way that the cache kind of works is Nginx in memory is going to have a hash table that it can use key values to look up, and it's going to save keys that are based off of the request that you're sending, and then the value is going to be the destination on disk where the information that it needs to respond with is going to be stored at. And if you have a bunch of files in one directory, it can be kind of hard to look through those things. But if you use subdirectories for things, then it is actually a little bit faster for Nginx to look those up. So we're always going to set this to be levels equal 1:2, which will set it to be a 2 subdirectory path style that it's going to use. And that's going to be underneath blog. So you'll see various things. It'll be like blog/c/12345/ and then some piece of content. We're going to spread this out onto a couple different lines here, but we're going to go with keys zone, and this is going to be the name. So we're going to call this blog, and then we're going to say any of the keys can be up to, it's going to be within blog, and then the size is going to be 10 megabytes for us. The total size of the cache, which is going to be max size, is going to be 1 gigabyte, and then anything past 1 gigabyte, we want to start deleting things from the cache, and Nginx can do that already, and it'll know what to remove. And then we're going to set one more that is going to be inactive equals 60 minutes. And that just means that after 60 minutes of not being accessed, we're going to remove bits from the cache. So this is configuration of how the cache itself is going to work. And then we also have to, in the same area where we're doing our proxy setup, we have to configure how the actual cache is going to work with relation to our proxy. So let's move down a little bit. And one thing we can set, and we're going to set it inside our server block here, is going to be fast CGI cache key. And this is going to be scheme request method. So whether it's a post, get, host, request, URI. And this is an exception to what I had said before about the similarities between fast CGI and proxy. And the reason for that, if we look at the proxy cache key, is going to be that it has a default that is the actual request. The difference here being that when we are proxying something to a application speaking a different binary protocol, is that it's not going to default to that same kind of HTTP path sort of thing. So we actually do need to manually set these. So this is going to be at fast CGI cache key. And you'll notice that there is no default in this context, so we have to do it ourselves. But by combining enough of the variables, we can make something that uniquely identifies any request that comes to our system. So the one that we've created here with the scheme, whether it was HTTP or HTTPS, the request method, the host, and the request URI, which is essentially the domain and the URL, this is sufficiently specific to what we need to do, because the only real difference here would be if somebody was trying to send a post or a patch for a create or an update. If this were a RESTful system, you wouldn't want to cache those anyway, because you really only want to cache get or head requests for the most part, because that's reading data, which is less likely to change than if somebody is actually posting something where they should be modifying or creating something within the system. Moving on, we're going to go down into our location block with our actual fast CGI setup here. And we're going to do fast CGI cache, which takes a name. So this is, we had to define it with cache path up top, and now we can do blog. And then the next one we're going to add here is going to be fast CGI cache valid for 60 minutes. And the cache valid bit here is really one of the areas that you can fine tune the performance of your application in the cache. If you make this really, really long, then that means it's going to be hard for you to update the information on your site. But if you make it really, really small, then you're going to have more requests going through to your application. What you can do to kind of really get this right for the application that you're working with is you can kind of sync this up with how long it takes for your content to be updated or for you to push out changes to your application. So if you know that you only deploy once a day and that no dynamic content is created, then you could have your cache be valid for an entire day. And then every time when you deploy, you could just wipe out your cache. And then the first request that is made would be the only request for each individual piece of content that your application can serve up until the next day when you have probably done a deployment. So we're going to look at cache valid more in the next video when we talk about microcaching, but you can realize that this is where you're going to do a lot of the tuning for whether or not you should cache things for long periods of time or short periods of time. And I like to sync these up with the inactive, remove it for 60 minutes, or it's cache valid for 60 minutes. This kind of just ensures that after an hour, something is going to be removed. So let's save this configuration and make sure we didn't mess anything up. Reload Nginx. If we head back and we take a look at our inspector here, let's go to the network tab. Make sure that disable cache is no longer checked if it was still checked for you. I know sometimes these things can stick around longer than you expect them to, and it makes it weird to debug things. But the next thing we're going to take a look at is going to be actually going to blog.example.com, and ensuring that we're not signed in. And yeah, as you can see here, I am signed in as admin. And if we refresh the page one more time, we're going to see this request that's a get for /, and this just means this is the actual kind of body itself. And if we click it, we can see headers. And this is really, really useful information to us. So this is good for debugging things, but you can see that there's a response header of cache control, no cache, must revalidate max age. And what this means is that the WordPress application sent this header back to Nginx. This is the header that Nginx looks at to know whether or not it should write something out to disk. And in this particular case, it's not going to do that. And the reason that WordPress sent this was because we were logged in. This makes it dynamic at this point because these are changing things up here. And so it's not just static content. If somebody had made this same request, but they weren't logged in, then WordPress would have skipped adding this header and Nginx would have cached it. If we look in var cache Nginx blog, we can see that there's nothing there. That's because it didn't actually cache any things. So what we're going to do now is we're going to go and, not actually go into the admin panel. We're going to go and we're going to log out. And we're going to visit the website again. And we're going to see if there's any difference. So now if we click on this, you can see that the response headers don't show that cache control header of no cache anymore. And you'll see that our response time was 434 milliseconds. And if we refresh the page, you'll see that it went from 443 down to 293. But is that because it cached? And one way we can check this is by looking inside of the blog directory, and now you can see that it generated some subdirectories. So that means that Nginx wrote something to the cache. But unfortunately, knowing the timing difference here isn't a great way for us to actually go about testing our caching. So the next thing we're going to do is we're actually going to manually add a response header for ourselves by editing our blog conf here. And we're going to use a new one that we haven't seen yet. It's going to be add header. And this allows us to add a response header from Nginx itself, not necessarily from the side of the application server. And we're going to call this x-cache-status. And then we're going to return the variable of upstream underscore cache underscore status. And if we check to make sure there are no syntax errors there, and I realized now actually that I closed that kind of fast. Sorry about that. But yeah, so we're adding a custom X header here. That's x-cache-status. You could really call this whatever you want. This is just one that I've used in the past. And then this variable of upstream cache status is going to be really useful to us so that we can see whether or not it was a hit, a miss, or if there was some sort of issue. So with that line added, we'll save and quit, and we will reload Nginx. And now if we come back over here and we refresh the page, we can see that we have an X cache status here of a hit. And that means that we've seen this page before, and it was actually already in the cache, so it didn't ever need to make the request go all the way over to our application. If we go and look at a specific post, the first time we hit this post, it's going to take quite a bit longer. We're going to see X cache status miss, and then we're going to know that if we hit this exact same page again, that we should get a hit, because the second time around it was already cached. It's going to be cached for an hour in our context. And so this is really good for us. So WordPress is pretty smart about knowing what it can cache and what it can't cache based on whether or not we're logged in. And one of those things would be if we just go to WP admin. This is an admin dashboard. If we take a look at this response, you'll see that for this particular form, it actually doesn't care. But if we sign in, apparently typed my password wrong. When we actually sign in and we're looking at this page, you'll see that once we're in WP admin, we're getting no cache, must revalidate. And that's because it knows that everything inside this area back here is going to be dynamic. It's going to be from us writing our own posts, creating our own pages. So the application itself is smart enough to report back whether or not this content is cacheable. And if you are working with applications where the developers have already written out these proper response headers, then that's great. Then you're fine and you don't really have to worry about this too much. But if you know there are certain situations when you don't want to cache things, but the response headers aren't actually being set by the application that you're proxying to, then we're going to look at how we can manually decide whether or not we want to cache these things. And this gives us a good opportunity to take a look at setting our own custom variables using conditionals and also the other cache directives that we have access to that can tell it to manually bypass caching. So we're going to open up our configuration again. And like I said, we're going to use a custom variable. And we're going to do this using the set directive. And then variables in Nginx start with a $. We're going to call this skip cache. And then we're going to set it by default to be 0. And that 0 is going to be important when we look at the documentation for the actual no cache directive that we're going to be using. But the next thing we want to do is we want to use an if statement, which takes a conditional in here, which in our case is going to be request URI if it roughly matches the string of WP admin. And by roughly matches, I mean that's a case insensitive search. So if it's WP admin or capital WP admin, then if this matches, then what we're going to do again is we're going to say set skip cache to 1, and then we're going to continue on. And then inside of our location block, where we're actually configuring all of our cache interactions, we're going to use a couple different things here. We're going to have the fast CGI cache bypass, and that's going to be the value of skip cache. And then the flip side of this is going to be the no cache skip cache. And what this means is that if there is something in the cache, we're going to go past it and not actually serve what's in the cache. And then when we get the response back, regardless of what the PHP application says, we're not going to cache it. So using this conditional, or using this variable rather, and with this conditional to set it based on our location, we're able to explicitly not cache the content and go right past any potentially cached content that there might be. So let's save this. Make sure we didn't have any problems here. And we can't really, in this case, test it because the WP admin area is already telling it not to cache itself. But if we go and we look at the documentation for this, we can go and look at cache bypass. And you'll see that it takes a string, and if the string is not equal to 0, then whatever is going on, like, it won't be taken from the cache. So it's going to go right past the cache and not actually pay attention to it. And then similarly, if we go to the no_cache directive, it's going to take a string, and if it's not equal to 0, then it won't be saved. So those two things allowed us to explicitly bypass the caching. There are more tweaks that you could potentially make to a cache, but for right now, this is kind of the basics of how you can create a cache and get one spun up and understand what's going on there. But once again, if we look at the documentation and we just go up to the top of this page, we can see that there are quite a few different cache options that we have. Some of them, unfortunately, are not going to be accessible unless you're using Nginx Plus. So this cache purge is a really awesome feature that allows you to set up some mappings. So if somebody sends a purge request, like that would be the actual HTTP verb type, you could actually clear specific parts of the cache, but you'll notice that it says this functionality is available only as part of the commercial subscription. So this is an Nginx Plus feature only. And unfortunately, it shows up in the nginx.org documentation so that you know it exists, but we don't have access to it since we're not using Nginx Plus right now. But the caching that we're doing right now is one means of caching static content that's really not dynamic, and we looked at how not to cache some content. In the next video, we're going to take a look at how we can get past the cache invalidation problem, because that's really one of the hard things to deal with computers, is knowing when not to cache things or when to break the cache by setting an extremely short cache time and doing what is called micro-caching.